What I'd like to do is pick up where we left off in class, but we left off in different spots. So I'm going to start with this method 2, using logarithms to transform the original data to make it look more linear. So the way that I choose to do this is different for things that I expect to be power versus things I expect to be exponential. If I expect it to be a power model, then I transform both the x and the y by taking a logarithm of y and a logarithm of x, and I graph log y versus log x. This could be log base 10 or log base e, so the natural log, either one is fine. If I expect that it's going to be exponential, then I would try graphing log of the y variable versus the plain x variable. All right, so let's take a look at the data we were doing before with the fish length and weight. And the length, by the way, is in centimeters and the weight is in grams. I looked that up, and those are our units. And here I'm going to call this the log of the length, so the log of the x variable, and I'm going to let this be the log of that variable. So I'm just typing in log length, enter, it fills that in for me. And then in the next column I'm going to take the log of the y variable, which is weight, so log underscore weight, and in the gray box you type log parentheses weight, enter. Okay. So now I have columns that have the log of the length and the log of the weight, the log of my x, the log of my y. And I'm going to go back to the original graph I had of the data and change my axes. So first I'm going to replace the y variable with the log of the y. So that's log of weight. Notice that that did change it. It changed the bend, right? But it's not linear. If this had been an exponential, this would have straightened out my curve. Okay, so I have evidence here that this is still not linear, so I don't think that it's exponential. So I then change my length to the log of the length. And that looks to be much more linear. Okay, there's some wiggling going on up here, but not so bad. So let's add our analysis now. So analyze, regression, show linear, a plus bx. Okay, and then let's take a look at our residuals. So analyze, residuals, show residuals. And while I do have a value that's up and then down and then scatter, I still feel pretty comfortable with this because these points here are so widely spread that any one of these points on the other side would still make this look randomly scattered throughout my values. Okay, so this looks pretty good. Now I should be able to use this to make predictions. The only thing I need to be careful of is that I know what I'm substituting for, and I may have to make some adjustments to my calculations. So what I'd like to do is add a calculator page here and do an estimate for a fish that weighs 15 centimeters. I want to estimate what the weight of that fish might be predicted to be based on this equation. Okay. So I'm going to insert a calculator page. All right, and there's a nifty feature on your calculators that it will tell me if I enter stat dot, it pulls up a menu of things that I might want to access of statistics you've recently calculated. I want the regression equation. And then if I type x, it will give me that regression equation with the variable x in it. So this is the regression equation that we just calculated. It's not in a plus bx form, it's in mx plus b, but you can understand what it is. And then what I want to do is calculate what this is if x is, if I substitute for x. But remember that x here is the log of the length. So if I know that the length is 15 centimeters, what I have to do is substitute the logarithm of 15 in for x. Okay, so I'm going to do, I'm going to just hit the up arrow and hit enter. And in place of x, I'm going to make my replacement of the log of 15. Because my actual length is 15, and this x is referring to log of length. Okay, then we'll hit enter. And it gives me a number here. I need to interpret that correctly. This is, I'm going to go to the notes page just for a second. Okay, so what I had is the log of weight was equal to, and then I had a constant, plus the slope times the log of x, length. What I did on the calculator page was I got an estimate for the log of weight, and it was 1.6 something, right? So now you have to remember from algebra how to roll the log in order to get weight by itself. So this is log base 10 of weight equals a number. When you roll the log, you take the base, in this case 10, to the power of the answer of the logarithm, which is your exponent, and that should equal your weight, what's inside the logarithm. That's rolling the log, okay? We can do some more practice of this in class, but the idea is you have to undo the transformation.